Well, this is our 3D automatic optical inspection machine. And what we have here is the loader here, the automatic loader. The boards are loaded in there. The scanning head is here. And the boards pass through and then into the automatic unloader at the rear. Most AOI machines function by taking a digital image in the 2 dimensions and do a comparison between a good board and the board under a test, and also do some image recognition to recognize characters on the surface, letters, numbers, to check that the right component is fitted, and also to check the orientation's correct, the right rotation. This machine does all that, but in addition it takes a measurement of the 3-dimensional state of the board, and it does this on a 20 micron mesh. If you can imagine that over the surface of the board, on a pitch of 20 microns, it measures the height of every feature on the circuit board. So this creates an enormous database of dimensions in the sort of Z-axis. And from this database, the operator can program specific tests which measure the volume of solder joints on a particular component, or the height of a leg, of a gull wing leg perhaps, to identify whether it's been lifted or not, or it might be the height of a board grid array to check that it's soldered perfectly flat. It can measure the inclination of the BGA to a very, very high accuracy. And obviously, you might be aware that if a BGA doesn't solder flat, potentially some of the balls underneath may not have been reflowed.
So what we are doing here is we're looking at components leads. In this particular, it's the 66W0827. And we're going to a tip of every lead using a locator, which can be seen here. So we found all the leads, and now we found all the leads, we go to the tip of the leads, and we measure a height check. So we do a mean height check for this one. We've got a little square here, and then this square shows us this data. This is all the points, all the ends of the leads put onto one graph. And this is what we allow through, and anything outside of this is failed. And yeah, that's how we do all our lead checks. Shows any lifts, any faults, any fails, we'll find it.
Just to demonstrate the 3D capabilities of the machine, we can just look at the screen here, switch it to 3D mode, and say we want to look at this component here, just draw a box around it, and then you've got a 3D image of that component. Just rotate it there. You can turn it round. Look at it from the other side. Now this isn't how we inspect the circuit boards, but it actually demonstrates the power of the data that we've collected to recreate a 3D image. The beauty of this machine is that it enhances the inspection capabilities by a factor of 10. On a conventional 2D inspection machine, you might expect to find 99% of the faults, but with this added 3D dimension, you would expect, and we do, find 99.9% of the faults. So it improves the ability to detect faults by a factor of 10 over the traditional machines. And that means better quality assemblies.